In this module, we'll explore the meaning, importance, and structure of a hypothesis in academic research. A hypothesis is a tentative answer to a research question. It provides a direction for study, can be supported or rejected based on data, and is given for something that happens or observed. A good hypothesis is specific, measurable, and based on existing knowledge. It clearly identifies variables and can be tested empirically. The two main types of hypotheses are the null and alternative hypothesis. The null hypothesis, which assumes that there's no relationship between variables, it serves as a default position that researchers aim to test against. The null hypothesis is typically denoted as H0. The alternative hypothesis opposes the null hypothesis. This hypothesis proposes that there's a potential effect or a relationship exists between variables. The alternative hypothesis is typically denoted as H1. Consider the question, does sleep affect academic performance? The null hypothesis states that sleep has no effect in academic performance, while the alternative hypothesis suggests that more sleep improves performance. Other than null and alternative hypothesis, there are also other types of hypothesis which are the simple, complex, directional, non-directional, and causal hypothesis. The simple hypothesis posits a direct relationship or difference between variables. This is also known as associative hypothesis. Simple hypothesis predicts between key variables in the entire research. For example, if a student studies for an hour, then their test score will increase. This is a simple hypothesis because it predicts a direct relationship between two things, studying and test scores. It's also easy to test and see if it's true. Complex hypothesis predicts the relationship between multiple independent and dependent variables, making it more specific but also more challenging to prove. For example, increased daily exercise and improved diet will lead to greater weight loss and enhanced mental health. This is a complex hypothesis because this example has more than one cause, which are exercise and diet, and there's also more than one effect, which are weight loss and mental health. Directional hypothesis predicts the specific direction or relation between variables. It indicates whether one variable has a positive or negative effect on another. For example, increasing the amount of study time is expected to improve test scores among students. This is a directional hypothesis because the statement predicts a specific direction. More study time leads to better test scores. It says something will happen when something changes, which is improvement when there's more study time. Non-directional hypothesis indicates the presence of a relationship or difference between variables without specifying the direction of the effect. For example, there is a difference in performance between Group A and Group B. The statement is non-directional because it only says there's a difference between Group A and Group B, without saying which group will do better. No specific direction is predicted. A causal hypothesis suggests that one variable, the cause, directly influences another variable, which is the effect. A cause and effect relationship. For example, higher temperature cause an increase in ice cream sales. The statement is causal because it says one thing, higher temperature, directly causes another thing to happen, which is more ice cream sales. Cause and effect. In research, hypotheses guide the study's direction, shape the methodology, and support the interpretation of results. A clearly defined hypothesis is vital for academic research. It ensures your study is focused, measurable, and scientifically grounded.